I told you F1 cars can corner at 5.5 times the force of gravity? That's your body suddenly weighing 900 pounds while squeezing through a turn. At top speed, it creates over 1,500 pounds of downforce, pressing it into the track. And here's the crazy part. One loose bolt could end an entire championship. I'm about to break down the 6 systems that make this possible. Each one is pushing the absolute limits of physics. Let's go. So here's the thing about Formula 1. It's not really about building the fastest car, it's about building something a human can actually survive at 200 miles per hour. So the cockpit is basically a carbon fiber safety capsule that can absorb impact over 30 G without breaking apart. That makes the driver safer than literally anyone else on the racetrack during your crash. But speed isn't even the hardest part. You know what's wild? The steering wheel looks like something from a fighter jet, 25 different buttons and switches. At 200 miles per hour, drivers are multitasking like crazy, adjusting the brakes so the wheel don't lock, changing engine settings to save fuel or add power, opening DRS for extra speed and talking to the team over the radio. And they're doing all of this just inches away from other cars. Then comes the cornering forces. Imagine someone shoving your head sideways with 80 pounds of pressure, lap after lap for 2 hours. Most people will black out. That's why F1 drivers train their necks like bodybuilders, because the 10-pound helmet can suddenly feel like it weighs 55 pounds. But here's what's incredible. Controlling this car is only possible if it can actually grip the road at those speeds. And that's where things get really interesting. A Formula 1 car is basically a wing turned upside down that hugs the ground instead of flying. At maximum speed, it generates over 1,500 pounds of downforce. Think about that. There is literally 3/4 of a ton of invisible force pressing this thing into the asphalt. Here is how it works. The front wings acts like upside-down airplane wing, forcing air to move faster over the top than underneath. This creates suction that yanks the car downward with about 500 pounds of force. But the real magic happens underneath. That tiny gap under the car, it turns the entire bottom into a massive suction cup. Air gets squeezed and accelerated through there, creating this low pressure zone that literally pulls the vehicle toward the track. You know what's genius? On the straight, DRS opens part of the rear wing, cutting drags by 15% for higher top speed. It's like having aerodynamics that adapts in real time depending on what you need. Every single surface guides airflow somewhere critical, cooling the brakes, feeding the engine, maintaining clean air. And here's something that blew my mind. When you're following another car, that turbulent air reduces your downforce by 30%. That's why overtaking is nearly impossible without DRS or massive power advantage. But all that downforce means nothing if your connection to the track can't handle it. So here's most people don't realize about F1 tires. They're not just rubbers. They're engineered compound that only work in specific temperature windows. Soft compound grip like they're melting onto the track, but they will be destroyed in just 10 to 15 laps. Hard compounds last much longer, but only hit the heat-perfect temperature. Miss that window by even 20 degrees and you are basically ice skating at 200 miles per hour. Before each session, teams wrap them in heated blankets at 160 to 190 degrees Fahrenheit. Once they're on the car, drivers have maybe 2 corners to get them onto the sweet spot around 200 to 230 degrees Fahrenheit. Fail at this and your lap time just became irrelevant. When everything dialed in perfectly, the surface actually becomes sticky during cornering, maximizing contact with the asphalt. Push too hard and the overheat becoming slippery and dangerous. Teams have entire specialists analyzing tire data, temperature, pressure, compound degradation, because championships worth millions have been won or lost over how well you manage 4 pieces of tires. And when those tires finally give up, there's one system designed to save your life. F1 cars are literally designed to crash. The cockpit can absorb impact over 30 G without deforming around the driver. But the most obvious safety feature is that titanium bar above the head called the hill. Get this, When it was introduced, drivers absolutely hated it.
When you look at the car, if it's ugly, you know, Formula 1 cars aren't ugly. They're not meant to be ugly.
I think as soon as I have that thing on my car, I don't like it, and I'm not even sitting in the car.
If it looks shit, it is shit.
Now it saved multiple lives. So the Halo can take 125 kilonewton of force and deflect debris flying at over 150 miles per hour. It's probably most famous for helping save Romain Grosjean during that terrifying Bahrain fireball crash in 2020.
In 2020, Formula 1 driver Romain Grosjean walked away unharmed from this inferno, shielded from harm by, you guessed it, his halo.
Here's what's brilliant about the design. Impact structures are built to break in very specific ways. The nose cone crumple piece by piece, absorbing energy gradually instead of stopping instantly. Side structure bend forces around the cockpit like water flowing around a rock. On top of that, fire system can flood the cockpit in milliseconds. The driver's suit can handle flame hotter than 1200 degrees Fahrenheit for over 12 seconds. And even the fuel tank is built to seal itself after a huge crash. You know what's really cool? Every crash becomes a live experiment. Sensors measure forces in real time, giving engineers data to build even safer cars. Survival isn't like here, it's engineering precision. But none of this matters without the heart of the machine. So, today's F1 engine are 1.6-liter V6 turbo hybrid that spin to 15,000 RPM and produce over 1,000 horsepower total. But here's what blew my mind. They recycle energy that would normally just disappear. Think of it like a smartphone that charges itself while you are using it. The MGUK captures energy during braking, stores it in a battery, then releases an extra 160 horsepower for 33 seconds per lap. That's often the difference between defending a position or getting overtaken. The MGUH is even smarter. It's connected directly to the turbocharger and harvests energy from exhaust gases, spinning the turbine, but it can also spin the compressor when exhaust flow is low, completely eliminating turbo lag. Imagine a tiny electric motor that can turn your turbo like a windmill on demand. Then fuel flow is capped at 1 kilogram per hour, so efficiency becomes obsessive. This engine achieves around 50% thermal efficiency, meaning half of every drop actually moves the car forward. Most world cars struggle to hit 35%. Cooling is absolutely critical. Without those radiator and oil coolers hitting in the side pod, this thing would overheat in under a minute. Every DAC, every vent is designed to keep that tiny rocket alive. But even with 1000 horsepower, you still need to stop in less than 300 meters. F1 suspension isn't built for comfort, it's built for extreme precision, able to handle forces so strong they will destroy a normal car. It uses a smart system of arms, rod, and spring that acts like little mechanical helpers. Each one manages how the wheel moves, making sure the tires stay flat on the track even when the car jumps over curbs at 200 miles per hour. Every tiny movement is designed to keep the car gripping the road and balance in the airflow. But the braking system, that's where physics get pushed to its absolute limit. Formula 1 cars use carbon brake discs, the same material you'll find in fighter jets, and they are powerful enough to stop a car from top speed in about 100 to 120 meters, basically the length of a football field. When drivers slam on their brakes, the discs heat up nearly 1800 degrees Fahrenheit, so hot they glow orange. To keep them from melting, cool air consistently flows through special brake ducts built into the car. Drivers also have the ability to adjust the brake balance while racing, shifting stopping power between the front and rear wheel to stay stable even in the middle of a corner. And the forces are insane. Under maximum braking, they experience up to 5G. That's like having 5 times your body weight thrown forward. It's the equivalent of trying to stop a missile with perfect precision. And somehow these drivers do it lap after lap. So here's what gets me about all of this. Formula 1 cars generate massive amount of data every single lap. All of that engineering exists so one human can make hundreds of split-second decisions while experiencing forces that will knock most people unconscious. We've built the impossible and made it drivable. That's Formula One. Thanks for watching.